our final section in the unit on systems of equations, we're going to go to the appendix, section C.2, which is talking about linear equations in 3 variables. So we're going to have 3 equations with 3 variables, x, y, and z. The solutions are ordered triples, x, y, z is the order, that are true for each equation in the system. So to check a solution, what we're going to do is we're going to substitute the values from the ordered triple and show that all of the equations are true. When we go about solving a problem on our own, we're going to come up with one of 3 possible solutions, just like when we had a system with 2 variables. So our possible outcomes, we could have one solution, which means you just get an answer, an x, y, z ordered triple. You could have no solution. If you get a false statement at any point in your solving, then you have no solution, which, if you recall, is represented with the empty set or the empty set symbol. You can also have infinite solutions, and that happens if you get a true statement, and it's represented with the set where we have our ordered triple x, y, z, then our line, and then we list an equation. So our first example, we are just going to check if the given ordered triple is a solution. So we're going to substitute in the given values for x, y, and z and show that it works in all 3 equations. So I'm going to multiply 4 plus 15 minus 15. No, I don't know how that 4 got there. 2 equals 2. So yes, that works. And then we substitute into the middle equation. Negative 8 plus 15 plus 12. Does that equal 19? So let's go with negative 8 and 15, that's 7. 7 plus 12 is indeed 19. One more equation to go. Negative 2 minus 15 minus 3. So that's negative 17, 18, 19, 20. It does indeed equal negative 20. So our answer here is yes, that given ordered triple is a solution. Part B, we have our x, y, and z, new set of equations. Uh, 16 minus 15 plus 2, does that equal 18? 16 minus 15 is 1, plus 2 is 3, not 18. So I can stop right there and say that my answer is no. So how do we solve on our own? To solve a system of 3 equations with 3 variables, the first step is to make sure all the equations are in standard form. So you have your x, your y, your z equal to your number. Then you're going to manipulate one pair of equations such that when they are added together, one of the variables will cancel. Then you're going to go back to the original set of equations and pick another pair of equations. And you're going to manipulate them such that when they are added together, the same variable as in step 2 will cancel. Using the equations from steps 2 and 3, we're going to solve with the elimination to get 2 of our 3 variables. And then we're going to substitute that answer into an original equation to solve for the remaining variable. And so how do we do that? I have 3 equations. Each is x, y, and z. I'm going to pick, do I want to make the x's cancel, y's cancel, or z's cancel? In this particular problem, I would say x's or y's, because each of those has a pair with the same number on it. So I'm going to go with the x's because they have a pair with ones negative. And so I'm going to take these two equations and I'm going to cancel the x. To do that, I'm going to multiply one of the equations. I'll just pick the top equation by -1. So when I do that, I get positive x plus 5y minus 6z equals positive 24. And then carrying over the bottom equation, and adding them together, I get y minus z equals 3. Now I go back to my original 3 equations and I pick a different pair. So I'm going to use the top one with the second one. And I'm going to cancel the x again. And to make the x cancel, I'm going to take the top equation. Now I'm going to take the second equation times by 5. So if I take that second equation times by 5, and then just copy down the top equation right there with it. When I add them together, x's are out. I'm going to get negative 29y plus 32z equals 99 negative. Now I'm going to take this equation that I just made with that other equation that also has y and z, and I'm going to solve by elimination. So I'm going to pick the y or the z, it doesn't matter which one, I'll just choose y, and I'm going to take this equation and I'm going to multiply it by 29. So that x, this is not the variable x, that's multiplied by 29. So we get 29y minus 29z equals 87. Copy the other equation right underneath it. And I add them together, the y's cancel, and I get 3z equals negative 12. So z equals negative 4. Take that negative 4 for z, put it back into one of these other yz equations. I'll use this one here, it's easier. Y minus negative 4 equals 3, so that's really y plus 4, so then I subtract 4 and I get y equals negative 1. So now I have y and z back into an original equation to find x. So I'm just going to pick this middle one. I know these 24s are going to cancel, so I'm going to have x equals 5. And then I write my answer as the ordered triple 5, negative 1, negative 4. And there are some more examples on the next video. If you are looking for some more problems, go ahead and see the next video.